Hi, my name is Erandika. Today we try to understand how to test a most critical uh, test in mobile testing, that is called understanding the response times. So for that I have a sample application where I'll try to demonstrate when application gets slow, how to understand why it's slow. So basically there are two factors we need to concentrate on this. First one is the network factor, the second one is the internal processing factor of the handset. So let me run this application and I'm just signing on now. You see the application response is pretty much slow. Still the application is rendering, and you see now we got the response. It's almost taking about 20 seconds. So let's see the first factor of the things that we need to monitor, that is actually the network. So for that I'm using a tool called Arrow. This is Arrow. I already recorded this this one while I was doing it because it's taking a bit of time. And you see these are the network calls actually happens during this test. And you see most of these network calls are content related, because you see these blue color lines are actually about downloading content, and this pink color one is SSL negotiation, and this yellow color one is actually the networking response times and the DNS lookups. Okay, now see all of these network calls are responded, especially this part, under 3 seconds. So the network time is pretty much okay, because I see the total response took about 30 seconds, and within that it took only 3 seconds, less than 3 seconds. It got actually some responses came less than 2 seconds, 1.22 seconds. So therefore we are not going to consider more network because it's actually responded within the threshold. So let me close this and let us load the Manuji and try to understand the internal handset optimization factors. Especially on this test, I'm going to look at something called GPU response times. Let me load the application again. Okay, now let's record the same scenario using Manuji. I hope you guys can see this. Okay. All right. Now I'm ready to record the scenario. So what I do here, I'm just clicking this record button in Manuji. Now Manuji is ready to recording, and now I'm going to do the sign in from the tablet. So I click the login button. Now again application is doing its processing, and Manuji is actually doing the recording right now. Okay, now the rendering part done. So let's take off this out. We'll stop the play. So there's a stop button here, so we stop it. from here actually then you need to select your application process, that is your application name. So I'm going to select this is my application. Right now you see the Manuji has displays his main the graph for you to do your analysis. So from here actually basically this is your main graph which displays about the CPU and the memory information mainly, and here you have the GPU analysis, here you have the rendering analysis, the memory and the energy. So for this response type analysis I mainly concentrate on these two graphs. Okay, now what we do first is we'll try to change the main graph to first we go into the rendering analysis, and let me draw the graph again in the main, and you see while I was in this sign on screen, you can see the sign on screen here, right? While I was keying the password, there are about 200 frames were loaded, and at the time that I am terminating the application, that is somewhere here, is actually around 700 views were rendered. So from 200 to 700 number of views, you can see its views, it's keep on increasing, and it got stabilized after you fully rendered this thing, this graphs, this screen. Now when we analyze the number of frames it rendered during the total test, that is somewhere here to here, it's actually 6 stable, and the number of bytes it used to rendering this thing that we call display list size is about around 2.75 kilobytes. It's almost static. Now the problem is, if those two factors are static, then how come number of views got increased? So basically here what we need to understand is what he doing this part during this. So for that we try to change this into the GPU part. This is where the actual render got happens. So GPU actually happens normally on 3 steps, that what we call draw, process and execute. So this is the drawing time taken by this particular operating system. It's actually less than 1 second. You can see this graph is very much minimum, and 16 millisecond is the industry standard. So this part is fully okay, we have no issue with this. Then we go into the process part, and here you can see clearly the process sometimes takes more than the expected threshold of 16 milliseconds, and here this part takes more. So now we need to understand we are getting more views, and this GPU process takes more time to do this processing because the number of views getting. And now here you double click this, you can see the sign on screen, and here you go, you can see this particular screen which actually got slowed. And if you analyze the execute time also, you see it's actually way above, somewhere around 40 seconds to actually doing this execution. So now we know which frames it caused this problem. We know the networking is not the culprit of this issue. So now then we need to look at the number of views, why that view count is going high, because there's another factor we need to consider here. This application is a PhoneGap build application, therefore I suspect the developers using WebView in an unmanaged way. So that part is actually we need to sit down with the development architects and do thorough analysis on this part, and we can find it and optimize it. So this is just icebreaker where the capabilities of Manuji. So I'm inviting you all to use the tool, and let's have another discussion maybe next time, and post me your questions so I'll try to answer them as much as I can. Thank you.